Hello everyone, welcome to this tutorial session where we're going to look at the one sample t-test. So the one sample t-test is one of the statistical tests, which can be used to compare means. So this is the first of a series of statistical tests which we're going to look at, aiming to compare mean values. So first of all, before looking at how to carry out the tests using the SPSS software, let's look at it in the context of an example. So suppose we have a research question which is there a difference between the average IQ of students and the world average IQ of 100. So normally, the world average IQ is assumed to be 100. So IQ tests are developed in such a way that the average always falls at 100. The score 100 is always 100. So let's say we just have a basic research question like this for the sake of our example. And imagine that we had collected data from a small sample of students at UM, and our goal is to actually see whether the average IQ of UM students can be expected to be different from the average IQ of 100. So when I say different, it could be, of course, larger or smaller. So our hypothesis would be, so H naught, which is always the hypothesis of no effect, our assumption, the null hypothesis, as we call it, the null hypothesis, our assumption would be there is no difference between the average IQ of UM students and the world average of 100. I'll just write it here. Whatever is here within bracket, you just need to replace it here. And what would be the alternate hypothesis, which is your claim? You can write it as H1 or HA, doesn't matter. So that would be there is a difference. So that's a claim we are making, that there is a difference. Of course, you can instead make a one-tail test, in which case you will specify larger or smaller. But we're just going to stick to saying that there is a difference without specifying larger or smaller. So unless there is a theoretical argument to expect the difference to be in a certain direction, then it's better to just assume, it's better not to specify a direction as such. So H1 would be there is a difference between the average IQ of UM students and the world average of 100, right? So that would be H naught, there's no difference, and H1, there is a difference. What we can express it in symbols is simply here what we're saying is that mu is equal to mu naught, so the real average IQ of UM students represented by mu is equal to the assumed mean value, which is a world average here, and the test value, as we can call it. So we basically want to compare it with a test value of 100. Is the true average IQ of students the same as the world average of 100, or is it different, which is represented by our alternate hypothesis, basically saying that mu is not equal to mu naught. Okay. So again, what does mu represent? Mu represents the average IQ of students. What does mu naught represent? Mu naught represent the reasonable assumption of a test mean value. This mean value against which we want to compare our true, real mean value. In this case, we're looking at average IQ of students, and we'll compare it to this assumed value of 100. In this case, in our example here, it's 1 and 100. Right? That's mu naught. So that's what we're saying here. So here we're saying that mu is equal to 100, and here mu is not equal to 100. That's what we're saying. Right? So now that we have set the setting of the study, so now let us proceed with carrying out the test on SPSS. Okay. So performing the test now using SPSS. So that's what we go for. Okay. So let's go. So we'll just now shift to the SPSS software. Bear with me 1 second. So here we are. So we have here a data set, and you'll see that we have a sample size of 70. So therefore, a sample of 70 students were actually surveyed. So we administered an IQ test to them, and those are the that's the data collected. So for the 70 students. So now let's proceed and do the one sample t-test. So to do the one sample t-test, we go on analyze, compare means, and one sample t-test. So that's what you want to do. Analyze, compare means, one sample t-test. And so that's the IQ score. So we're going to select IQ score, and the test value, that's the reasonable assumption of mu naught, and as we know it's 100. So we're going to compare this value with the value of 100, and then we say okay, and here we get the results. All right. So that's our descriptive statistic here. So IQ score, the mean value is 106.96, and that's a mean value calculated based on the sample data we have, the sample of 70. So we get a mean of 106.96 and a standard deviation of 12.452, and that's the standard error of the mean. And this is the result of a one sample t-test. Right, that's a result of a one sample t-test. So let us now interpret the results. Right? So that's the result. So as you see, it's quite straightforward to carry out the test on SPSS. I'll repeat the steps again. In any case, you can easily go back to the video and watch it again. So analyze, compare means, one sample t-test. You can play back the video and see how we actually run the test. Super easy. You got your results here. Now let us make sense of it. So what I will do here, we'll just copy that. Let me just copy that. We set our results here, and we're going to make sense of it all. So very good. Let me just copy that and go back to our PowerPoint slide. Open that, and here we are. So now I should first paste this. Okay. Increase that a little bit. Okay, excellent. And now we are good. So maybe I should use another color here. Let's use color blue. Okay. So first thing to note is that that's our calculated mean value. So that's represented by X bar. So average, what is this? Average IQ of students, okay, calculated from observed data that we have. That is a sample of 70. So that's what we know, and that's what we know, and we represent it by X bar. We use a different symbol. We don't use mu. We use X bar. So X bar IQ is equal to 106.96. So this is our sample mean value, what we refer to as our estimated average, estimated mean. Our estimated mean. Now, as you know, we cannot be 100% sure that this estimated mean value is actually the real mean value, and we'll never be 100% sure, by the way. But the whole purpose of actually carrying out the one sample t-test, and that's the case for any inferential statistical test that we carry out, the goal is to actually verify whether whatever estimate that we have obtained can actually be confidently inferred to our study population. Is it something which we might just be obtaining? In other words, is it something which we might just be obtaining out of sampling variation? Or is it something which is likely to be true, likely to exist, the effect that we're observing? So what are we speaking of here? We are here looking at whether there's a difference between mean values. Let's recall, what's our research question? Our research question is there a difference between the average IQ of students, the real average, the true average, but we don't need to say it, that's implicit, and the world average of 100. To find an answer to this research question, we carried out a survey, and in our study, we were able to collect data from a sample of 70 students. Let this be very clear. So from this sample of 70 students, we calculated the mean value, and we got a mean of 106.96. Now the question that we attempt to answer is, how likely are we to obtain such a value when actually there might be no effect? And this is what our test tells us here. All right. So basically, if we needed to represent that, it's simply actually looking at t distribution. And of course, the exact distribution depends on the degrees of freedom. So just suppose it's something like that. And what we're saying here, so if actually the true mean, so mu is equal to mu naught is equal to 100, right? So there's no difference. In other words, no difference, zero difference. That's what is this represent. The difference is zero. In other words, mu minus mu naught equal to zero. So you do still expect, due to sampling variation, because we took a sample, to observe some kind of difference. But then we see at one point, the difference will be so big that it could be quite unusual to observe such a difference. Now, those two are supposed to be symmetric. I'm sorry for the bad drawing skills. It's supposed to be the same here. So what we're saying is that, so how likely it is that we observe an effect as large or a larger effect when actually mu minus mu naught is equal to zero. Right? So that's the answer we try to find here. So what we get here is a t-statistic with 69 degrees of freedom, which is 4.6, quite large, and a p-value of 0.000, less than 0.05. That's our significance level, as you know. Right. So at the end of the day, we can just look at this and interpret that, for those of you who don't want to go through the whole. I mean, it's important that we understand what's happening, but at the end of the day, when interpreting the results, the software already provides us with the p-value, and we can just focus on this one. And if p is less than 0.05, what do? We reject H naught, because basically that means we have a lot of evidence, we have large evidence against H naught, because the probability of observing such an effect, or a larger one, when actually H naught is true, that in truth there was actually no difference. This probability is very small, so we can confidently reject H naught. That's what we would say here. Okay. I hope this all makes sense. And as a conclusion of our results, what we can say, we're going to write something like that. It's very important to know how to report. So the full interpretation and reporting of results is super important. So in this case, we're going to say something like that. So the average IQ of students was hypothesized to be different from the world average of 100. So here you can actually write what was the mean. So mean actually was 106. Let me see again, 106.96. So deviation 12.452. St is equal to 12.452. And you can also write the sample size actually, which was 70, and equal to 70. So that's basically what you can write here. I should have written it here. Okay, and so the observed difference, which we find, so the observed difference, because from sample data, we see that we have a difference. So the observed difference, which is x bar minus mu naught. So basically, the observed difference x bar minus mu naught, which is this one, minus 100, which is 6.96, was found to be statistically significant. This difference was found to be statistically significant. And you can see at the 5% level of significance. And at this point, you might want to report the t-statistic. So we can say t69 is equal to, it was 4.675, 4.675, and you get a p-value which is 0.000. So that's a t-value here, and then that's the degrees of freedom, and that's p 0.000. Okay, 69 here, the degrees of freedom, and this is less than 0.05, our significance level of 5%. Well, unless stated otherwise, we always go for 5%. But if there are some reasons to use another significance level, then definitely you specify it here. Right. So that's basically how you would interpret the one sample t-test results. Now, there is an additional step which we always want to actually include. It's the calculation of the effect size. Because whatever one sample t-test tells us about, since we have a low p-value and we reject H naught, this tells us that our result is statistically significant. Right. But it does not actually tell us how important the result is in practice. We might be having, could be because we have a large sample size, or we have small variability in the data, but even a very small effect can be found to be statistically significant, but not large enough to warrant practical decisions or actions. So of course, what type of actions, decisions depends on the field of study. In medical science, we refer to it as clinical significance. It could be whether we're going to use a particular vaccine or not. In management research, it would be something like taking a decision to invest or not to invest, to adopt a certain policy for improving employee motivation or not, to decide to go for the production of product X compared to product Y, to use a certain packaging or not. So you see what I mean, depending on the study. So do you really need to take action? Or is it so important? Or is it something that which is statistically significant? Is it an effect which is statistically significant, which means that it is likely to exist? We have confidence that it is true, a real effect. We are confident enough about it, but it might be so small that there is that we should not actually focus on it when it comes to practice. So for that, we always need, when it comes to what we refer to as practical significance, we actually need to look at the effect size. And in the case of a one sample t-test, the effect size which we use is the coherence D. Let me have a small box here. So the coherence D. Now the coherence D would, in the case of a one sample t-test, be super easy to calculate. So we just take the effect, which is x bar minus mu naught, and we divide it by the standard deviation, tout simplement. As simple as that. So calculating the coherence D gives us an idea about the practical significance. Practical significance. And how do we interpret the coherence D? So generally, a coherence D value of around 0.2 would be like a weak effect, a small effect. Around between 0.2 and 0.5 would be moderate effect. So 0.2 to 0.5, and above 0.5 is already considered to be a large effect. Okay, large effect. So that's a general interpretation of the equivalence D. So that's what we want to actually look at here. And well, there are some variation to the interpretation. In some textbook, they will say around up to, we should get something around 0.8. Let's be a little bit conservative about it and use that one. And let's say around 0.2 small, around 0.5 moderate, and around 0.8 a large effect. Now we can be a little bit flexible about it since there is no rule as such. It depends on the subject being studied, the phenomenon and the study as well. Okay, so let's use something a little bit more flexible, but at the same time a little bit more conservative regarding the interpretation. If I'm not mistaken, that's the one proposed by Cohen's. Okay, so we can just calculate it here, and what I will do in our case, I will just quickly make use of an online calculator and just calculate. I mean, you can easily calculate it by hand as well, but let me see if I can get all of a quick online effect size calculator. I can show you how you can easily make use of this. You have some very nice calculators. Yeah, I got one which is nice. So here it is. You can use it for the other effect sizes as well, what we're going to look at. Okay, so for example, we have this one, Statistics Kingdom, and yeah, so it also gives you some other effect sizes, and you might want to read a little bit about those different alternative effect sizes. Okay, so for now, I'm just going to for Cohen's D. So you need to insert here what's a sample average. So we got 106 point. So it was 106.96. Is it 106.96? And we have an expected value of 100. So what's our standard deviation? We get a standard deviation of 12.452, 12.452, right? And that's it. That's it. And so we can calculate, and that's our Cohen's D value. So which is, as we said, simply x bar minus mu no divided by s. So we get here a Cohen's D value of 0.56. And the nice thing about this particular website, it already tells you about what is the interpretation. So it exceeds the conventional medium effect size, which is d equals 0.5. So we get here, sorry, a medium size effect. Or we can say an effect which is slightly larger than what would be considered to be a medium-sized effect as per guidelines provided by Cohen. You have a reference here, Cohen 1988. Okay, so that's something we want always to include. So let's quickly do that in our reporting of our result here. So what we can say, so we get Cohen D value, calculated Cohen D value of, let me use the same color one, is it green? Okay, 0.56. And so what you can simply do then, therefore, is include a statement that the difference between the average calculated IQ of UM student estimated between the estimated IQ of UM students and the assumption well average is found to represent a medium effect, or it's larger even, you can say, than a medium effect. So the difference between the estimated estimated average. What are we saying here? Estimated average, or average IQ of students. So we're referring to vast difference of 6.96. So that difference in the world average IQ. Now you don't need to write it again if you want. You can just say to state it directly, but if you want, you can. So in the world average IQ, is found to represent a medium effect. It's a medium effect, and why are we saying that? We're saying that because the coordinates D is equal to 0.56, and that's important. That's a practical significance of the result. So this one represents the statistical significance, and the practical significance is represented by this one here. Okay. So that's statistical significance, that's practical significance. Okay. This tells you about statistical significance, while this tells you about practical significance, the effect size. Well, very good. We've reached the end of our tutorial on the one sample t-test. I hope your understanding was clear. And if ever there are any questions, please don't hesitate to reach out. Bye-bye, everyone.